Hey everybody, it's Eric. I'm diving into the afternoon forecast and thought I would record another session, seeing as we're looking at potential for some severe weather across Minnesota this weekend. So really quickly, going to dive in on this. I'm hoping to try to keep this pretty brief, maybe a few 15 minutes or so. So it would be quite the challenge for me, but let's do that. We've got a surface low that is moving across Canada, and that surface low is bringing with it a trough. That trough is kind of the definition that sits around that surface low. There is a short wave or a series of short waves that typically follow or come along with a low pressure system like that. And those are just disturbances in the middle of the atmosphere, but those create different boundaries, different forcing mechanisms and different things that can stir up the environment at the middle level as well as down at the surface. And so that's going to play a role in why there's a little bit of a potential and probability associated with the severe weather this weekend. But again, coming through that, there's a warm front that's just about over Minnesota associated with that low pressure, and a cold front not far behind it. Fairly weak cold front in that. And so the mechanisms for this and the mechanism for forcing are going to be fairly weak overall, but not insignificant. And the severe threat overall is not zero. So just want to talk through that a little bit more, but there's kind of three different distinct periods, Friday evening into Saturday morning, Saturday, into Sunday, and then Sunday into Monday. And a lot of these events will be timed with where that forcing function comes, as well as the daytime heating. So let's look at the SPC's outlook overall. So you can see this kind of nose that's kicking down into Wyoming area. This nose of marginal risk that's associated here. So this is for today. This is the overall convective risk, marginal 1 out of 5. Along with all of these are going to be very small and relatively low risk of tornado, but it's worth pointing out, though it's pretty much isolated to northwestern Minnesota. The greater risk for these storms is going to be wind and hail. And so you can see a matching wind risk and a similar hail risk to the tornado space that's there. So looking at that, now moving on to Saturday, the risk overall for Saturday increases to a slight risk. That is going to be driven not by this broad tornado risk, but primarily by this wind and a little bit of associated hail risk that are there. And so those risks overall are fairly well located at the higher levels to North Dakota, but they do broaden as you go. So if you go back here and you look at kind of our general area being mostly to the northwest, but then as we move in, that widens into a wider part of Minnesota overall. We're going to see the same thing, looking here Saturday, we're going to see that going into Sunday here. And this kind of opens things up in general. It is a little bit too early to be talking about details of Saturday afternoon or Sunday afternoon, but it's worth mentioning that the chance for greater Minnesota to see some precipitation is probably greater on Sunday afternoon, Sunday evening, and overnight into Monday than it is Friday or Saturday. So let's take a look at some analysis here. Just looking at jet stream overall, this is 250. Major point here, if I just were to draw really quickly the boundary of the United States, it's going to be very crude, rough, just for the purposes here. But you can see what's going on is this low pressure system that's sitting up here in Canada. And associated with that is a jet stream, that's always kind of moving around. You can see the general flow of this jet stream here and this general flow of the jet stream here, right? You can see these winds moving. And then this darker pink area is a jet streak. And this jet streak is a greater concentration of winds up in the jet stream. And so that will help strengthen and help that low pressure system carve a little bit deeper trough into this area. But you can kind of see where that would be occurring and where that jet stream is. That jet stream usually kind of dictates and shows where the trough and the movement of that system is going to be going overall. And so we'd expect to see, this trough developing, sort of like that as we look down into the lower levels of the atmosphere. So just kind of moving on here to water vapor. It's a lower level water vapor. Here again is that low pressure system. We can see we've got great counterclockwise spin that's there. we can see this dry slot coming in. It kind of gives us an indication that the low pressure system may be a little bit more mature than, just forming. And another thing that we can model out here, from that would be a cold front, something like that. And it's my crude cold front, and a warm front associated, that would spin out from this probably down through here or so, as it just on the edge of the Minnesota border for that. And then through here is where those two fronts have essentially met and created an occluded front. These down here are the primary ones that we're going to be watching as these come together and move then across Minnesota, and it will be the timing of, sort of these waves of the pressure system as it comes in, and that forcing, which will be a primary, accelerator for any storms being created. So just taking a look down here at the surface, again, we can see our low pressure system over here. Eyesight's a little bit weak, but that looks like 991 that's here, 991 or just below. So that low pressure system that's there. Here's our cold front that's kicking out right there, as well as this warm front that we talked about just a minute ago. And then, the occlusion of that would be, along through here as well. This will give you a good idea of at the surface, because this is so far closed off, the maturity of this, trough that's here. It's fairly large, right? Structure that gives you kind of an idea overall of again, the maturity of that and where it's heading and what's going to be the greatest impact. We are going to see some of the residual effects of this. I'll do this kind of in green here, right here, as this moves across in Minnesota, where this itself is going to continue to move off into the east. And so we'll see that occur a little bit more on the modeling as well. Taking a look at the sounding from this morning, just taking a look at MPX, we're due for another one here in about, in 2 hours or so. But just looking at this here for a moment, one of the things to note is this large temperature inversion that's here, right? Again, we talk about cap and temperature inversion a lot. That temperature inversion, if you think of this just even as a straight line like that, any of these parcels that are sitting down here, anything that's down here, and that's trying to rise, it's going to run into that as sort of a lid, and it won't have the ability to rise. And so as long as we have this little nose that's sticking out here, or we have this warmer air that's aloft, or above this air down at the surface, that's going to be a limiting factor for any of the instability or CAPE to be a factor in our storms. We will need something else greater than that to overcome that inversion. The other thing that you can notice here, in addition to that inversion, is this what looks like kind of a dew point, like a depression of that. And so this area in here is what we call an elevated mixed layer. This layer is warmer and drier than the area that's down here, which is much cooler and humid that's there. So it'd be very hard to get this warm, moist air to rise up in above warmer, dry air that's sitting above it. That's essentially what's called a cap. So that's the main feature that I wanted to point out here. There's some other things we might look at on some forecast soundings, but just kind of taking a peek at up north Minnesota along the border, very similar type situation that we have here, and that is a temperature inversion here, and here we have the little ones, as well as this elevated mixed layer that's here. So out of the gate, northern Minnesota starting out kind of in a similar place as we are in the Twin Cities this morning, though through daytime heating, a lot of this, the structural in this graph would obviously change, but that is kind of the baseline by which we're going to have to overcome for any of these storms to take place. Taking a look at the recent mesoscale analysis page. So just wanted to point out here, mainly this huge section here of very moist air that's sitting over most of Minnesota, with southerly winds, associated to this. There's plenty of moisture. When we talk about thunderstorm ingredients, that's one of the big ones and one of the most important kind of first ones that I might look at. There's plenty of moisture here at this level day at the surface. As we go aloft, we'll look at that changes a little bit, but at the surface, plenty down there, and you're probably seeing, these, high 80s and, mid 70s dew points, and it feeling very warm, but not super muggy. It's actually kind of a great day overall. So most of Minnesota seeing a generally good day. I want to take a peek now back up at that 500, which is the middle of the atmosphere. Here you can see the current placement of two things that are important. Is one, looking at these pressure gradients here, 5760, 5700, right in the middle of the atmosphere. And you can see this here. Here's the remnants of that ridge that was, with us for the last couple of days. Generally speaking, high pressure sitting down here, and that high pressure, keeping everything else away. And I always kind of think high pressure is it keeps everything away and keeps the weather really nice, right? That sitting there, that's going to move out as this whole system moves over towards the east. And it's going to be these differences in pressure, this pressure gradient, that will kind of swoop through, and that will be a major player in some of the forcing mechanisms that are there. You can also see from this, it's kind of interesting, but you can see that the temperature that's here. So if you draw these temperature areas, this is at the 500 millibar level. But what's interesting is if you look at these, pockets of temperature, you have these kind of just general areas, right? Just trying to make this a little bit easier to see. What you notice is, for the most part, what's sitting over Minnesota right now is these just broad areas. But what's behind it is, this temperature. You can see these gradients fill in much tighter. So as these get tighter here, that is essentially where a frontal system is. And so you have one big air mass sitting over here in red, and you have a completely different air mass that's sitting here and here and here. And that's all going to push through. And those different levels and different temperatures and, different pressure heights, that's all going to play a role in the ability for wind to move across them and be pushed up into the atmosphere to potentially overcome that inversion that we were talking about. So again, the last thing I'd show you on the 500 level is just looking at the pressure falls. This is showing you in blue where those heights are, decreasing. So this is where the height of the 500 millibar level is, coming down. And when you draw these pressure gradients out, right, and there's kind of our trough that we were seeing. We're seeing this general area over here is where that is, is that the height of the 500 millibar is lowering in the atmosphere with that. And that is all pushing this way. Would be the greatest concentration, where I'm just kind of over highlighting this in blue, would be the over concentration of areas, for severe threat and potential for storms. And that's all moving this way. It's just like the edge of it scrapes Minnesota. But what we're going to see with this is we're going to see it kind of in waves. And we're going to see, kind of wave 1 come through and wave 2 come through and wave 3. And you could think of it like that. And it's a little bit more gradual than that and not exact. But as the gradients come through, and especially then as the daytime surface, temperatures get up, those factors kind of, blend together in a formula, essentially science, right? That then is where the potential for storms could occur. So that's kind of what we're looking at overall. I want to look at some of the modeling here. So there we can see this is kind of zoomed out view of the United States. Here's the NAM. This was the 18Z run not that long ago. And this will give us the best long-term view of just overall atmospheric conditions. So if we just play this out, we can see, some of that ridge move out of the way, right? So we're going to see that ridge here weaken, and we're going to see these gradient, these pressure heights move across Minnesota. And as those move across, you'll see these areas that are kind of this light blue and purples and blues, yellows. That's vorticity, and that's movement and circulation of the air. And that is are going to be kind of concentrated areas of where we've got air likely rising associated with this system, and where convection and storms could be occurring. So we just kind of watch these go through. And, if we play this out and we look at tonight, right here about 7 p.m., we've got this upper, little part of northwestern Minnesota that's seeing some of that. But as we continue on, we're already into the morning of Saturday before we start to see any more, of that, these little blips of part of the shortwave that come through. And so, these moving through here into Saturday, you can see they start to move down as these pressure gradients right now are kind of making their way right into Minnesota. That's where you're going to start to see it start to cover more of Minnesota. And that's why it's going to be a little bit of a gradual kind of 1, 2, 3. And as we get towards Sunday, more and more of Minnesota has the potential to see some weather with that. So we're looking here now 4 p.m. on Saturday. So a little bit wider area of Minnesota now has potential to be covered associated with that. In this system, this is probably the timing here. Saturday morning and into Saturday afternoon is probably the potential of why that slight risk was for North Dakota. That pushes on through, and then you can see this shortwave that's coming on through here. You can see this, from the overall pattern of the jet stream that we look at this little funky disturbance that's coming right across that's going to impact Minnesota. So you think of this almost like a little mini trough within the bigger trough, and low pressure system, right? If you think of this as kind of the macro feature, this is the micro feature, if you will, embedded within that system. This is going to create with it this level of vorticity that's here, and you're going to see that line move across as we're looking now into Sunday afternoon. Here we go, kind of broader Minnesota now is in play, and we see that move across right here into Monday morning before things clear up. And then what we're going to probably see is a general trend back to this ridging system with high pressure, generally speaking, into kind of calmer, nicer August weather towards the end of the week. Or at least towards the beginning part of the week here. All right, staying with NAM, I just wanted to show this really quickly. This will give you a good idea. So now we've got this hot temperature from today's warming, right? You can watch this line that goes through here. You can see it develop right here, right? This line that develops right there, that's our cold front. You can see that line push through, and that's the beginning of that forcing function to come. And really before 7 p.m., here we hit 10 p.m., and here we hit into the 1 a.m. mark. As that's moving in, it's really only this part of Minnesota that really gets impacted before we hit the evening hours, and things in general start to cool off a little bit. And so that's kind of the first wave of that. Then we move into Saturday. You can see kind of another wave right there, right, moving on through. And so that's another wave, of these kind of forcing functions. And again, Sunday as we move through, you'll be able to see the same kind of right there, this broader system moving left to right through there into Sunday. And so those forcing pieces are going to be the necessary things to actually push us up and over that temperature inversion. Looking at relative humidity up in the 700 millibar. So we're a little bit above that inversion right now, but just what does the atmosphere look like to support if we were to get above that? Do we have the moisture above that level to keep storms going? So you can see right here into the 10 p.m. mark, we've got this great advection of moisture here into the northwest corner. This is what we've been talking about. So if any storms were to develop, they would have a better ability to sustain in this area where there is moisture aloft. The general rest of Minnesota is fairly dry, as we saw, that elevated dry area that's above. And so you put moist air up into that, and it just it doesn't support the instability that we would need to continue to sustain storms with that. Just playing this out a little bit into Saturday morning, you can see now that plume of moisture, expands into broader northwest central part of Minnesota. That continues on Saturday evening as well here. So now we're looking at kind of the overnight Saturday into Sunday morning. And this continues on until, Monday morning, where, from Sunday into Monday morning, we've got pretty much the entire state, with plenty of moisture above, by Sunday night to be able to potentially support storms. Just want to look at that 850 level again. So one thing you'll see here is, this very warm, area that we have, up, above us from the surface. As we get into the evening hours here, into the 7 p.m., you'll notice that the strengthening of this right here through this strong area, the low level jet, and you can almost see it really well on the 925 as well. As you look at this, here's where we are right now in kind of the just above the surface area. And then we look what's happening at 7 p.m. and then, 10 p.m. And overall, this lower level jet is strengthening. So any storms that do get created, we're shoving more warm air and moisture in there. And probably can see it very well. And here you can see it really well on the 850. There you go. Look at this jet that's just getting created in here. And so this will be, any of these storms that do get created up here would be supported by this low level jet as well. And that doesn't play as much of a role. Here you can see it is Saturday night here. But as we get into Sunday and that short wave is pushing through, that doesn't play as much of a role in the latter part of the weekend. We're looking at the thickness before and some of the pressure gradients here. This is kind of showing another similar view of that. And as we see, the forcing along some of these temperature gradients, you can see as those move in across, and here you go, we've got some stacked pressure gradients. You can see how the storms follow right through those. And that's pretty much where they're located too, until we hit this 5760, thickness. And when you look at that, that really does seem to be a pivotal kind of boundary layer that then supports some of these storms getting pushed up against it and created across Minnesota. So be watching this boundary line to see how much of that and how much of the rest of what the HRRR and NAM have shown us come to fruition. Speaking of HRRR, I wanted to show some of the instability and show kind of the key difference between what we were talking about here. It looks like a lot of instability, and if you weren't paying attention, you'd look at this and say, I'm here, Redwood Falls or one of these areas, and it's like I'm looking at almost 3,000 joules per kilogram CAPE, right? The problem with this is you got kind of two things going on, or kind of a couple things here. Yes, you have a lot of CAPE, right? A lot, plenty. You have a decent amount of convective inhibition or capping, right? That is occurring, and this is a model, right, of the sounding. And this is modeling what is happening at 7 p.m. So this is still, another hour and a half from now. And it's still projecting a pretty decent inversion here at the surface and another one up here, in the kind of, 800 millibar range. And so both of those are going to be challenges. Even when we look at values like that and think, can we break the cap? Well, in order to break that cap, we would need some of that forcing function. We would need a shovel, a wedge, if you were to think it like this, to lift the air up past this point so it could rise on its own. And we just aren't there from a timing perspective with this system that's coming through. And so while that certainly could be possible to break the cap, we're just off a little bit in some of the timing for that. This is another view that's here that's showing that inhibition. And so you can see most of northern Minnesota and central Minnesota is covered by this purple, right? And that purple is the inhibition. And look at these values, negative 200, negative 137. When we start seeing numbers negative 50 or greater in negative, it gets to be the point where no amount of lift really can help overcome that. Certainly no amount of heating the rest of the day, surface heating or mixing could do that, but we would need some pretty heavy forcing to be able to push and overcome that level of negative potential that's there. This changes up a little bit, but as you get into Saturday and Saturday builds out, look at the, lot of Minnesota as you get into Saturday morning and Saturday overall, a lot that's in there. It does break up a little bit into Saturday afternoon, but the primary areas where we were seeing some of the setup is up in here to the north. So it's going to be whether or not some of these areas, kind of central Minnesota, can these areas where we do have a good amount of CAPE, where we do have a very low amount of inhibition that's here, and an okay amount of shear, can these areas potentially support storms? And that's the possibility. I do think the greatest risk with these is going to be hail, and it would be very unlikely to see any sort of severe tornado or sustained storm like that from these. And then just moving across here, this is kind of a view of the HRRR's reflectivity. So showing, as we look kind of that first wave, here's that first wave and where we see it hitting Minnesota. We can kind of watch that as it comes across there. Now this is into Saturday morning. So we can come back here and move, our line for Saturday kind of moves over into this area. We can play this out just a little bit more and see, you can see there's a little bit more potential for these storms to develop down here. And now we're overnight into Sunday. You can see potential for some of this, to come in the evening hours here. This would be Saturday night, right? And now into Sunday. So across there. So that is, still the greater potential risk would be in where we're seeing that slight risk, right here on Saturday, that coming across, and then that playing out into Sunday, and then now Sunday afternoon. And just unfortunately the way the cams work is we don't have that much visibility into Sunday afternoon, and so we can look to some of the other blended models and other tools just to get an idea of where things might be. And so kind of looking at percentages of precipitation and really playing this out here. This is looking in 6-hour windows. And in this one, we can look here and by, Monday morning in that 7 a.m. mark and overnight is really where we're seeing the greater risk of, 60% chance of precipitation across broader Minnesota. One big caveat you need to know when you hear percentages from anybody is there's no real standard of what a percentage, means. In this case, it's precipitation over 1/100th of an inch. So it could drizzle a little bit and that checks the box here, and it could downpour an inch here and that checks the box here. So just one thing to keep in mind when you're looking at percentages, not all percentages mean the same, and it's really helpful to understand what somebody means by a percentage. And if they're not telling you, it's hard to interpret what that really even means. And so in this case, I can tell you these are 6-hour windows where NWS has a blend of models, 6-hour window where precipitation is over 1/100th of an inch. And essentially that window resets the next time. So we can kind of look at this rolling window here and look at different 6-hour ranges, over the course of the weekend. So that's a really quick summary. I was trying to keep it to 20 minutes. I think I'm going to keep it under 30 minutes. If you have any questions on this, let me know. I'm going to keep an eye on this and probably have another update as we get into Saturday, because we'll have better visibility on what Sunday looks like. And I do think Sunday, while the threat is lower, the storm system into Sunday is a little bit more widespread and impacting greater area of Minnesota. So we'll take a look at it that way. Hope you had a wonderful week. Hope you have a wonderful weekend. Take care.